Z2. Okay. It can also be written in this manner: 1 minus omega squared L2 C2. You can just multiply numerator and denominator by j omega L2, j omega L2 in the numerator and denominator, and you get this expression. Is this too quick to go from here to here? This good, right? You multiply numerator by j omega L2, you multiply denominator by j omega L2, and you get that in the denominator and that in the numerator. Or you want me to go through the detail? It's fine, right? You can catch that. So then by the voltage divider formula, V out omega is equal to Z2 over Z1 plus Z2 times Vs omega. So H of omega would be equal to V out of omega over Vs of omega, which is Z2 over Z1 plus Z2. And then you can plug those things in if you want to, which is j omega L2 over 1 minus omega squared L2 C2 divided by the sum of the two, which is j omega L2 over 1 minus omega squared L2 C2 plus 1 over j omega C1 plus j omega L1 plus R1. Okay, that is the transfer function if you want to write it up in full. Okay, and then part B asks you to find the transfer function of an ODE. The ODE is given by 3 d squared y dt squared plus 2 dy dt plus y t plus 2 df dt plus f of t. I can immediately write down the phasor equation for this. You can go through the detail, but it's not necessary, is it? I can just write down the phasor. Okay, so if y has a phasor representation given by this, and then f has a phasor representation given by f, okay, I can convert this into a phasor equation immediately and write down 3. What does d squared dt squared become in the phasor world? J omega squared, very good. Okay, and then y just becomes y. What is that? Did you make a mistake? No? Plus 2.
You said j omega squared, but it's j squared omega squared.
Okay, it's about the same, depending on where you put the square. Okay, and then y, and then you have 2 j omega f plus f. Okay, so this is the phasor equation for this. You want me to do the detail, or you can jump from here to here? It's fine, right? Most of you can jump from here to here. Okay, so you remember that this is actually 3 omega squared y, and then you solve this equation for h omega is equal to y of omega over f of omega. This is the input, this is the output, and then you get this to be 1 plus j2 omega. Okay, 1 plus j2 omega over 1 minus 3 omega squared plus j2 omega. So this is the transfer function for this equation. And then part C, you're given that f of t is equal to 2 cosine of omega 1t plus sine of omega 2t plus theta 2. Okay, that h of omega is 1 plus j omega over 2 plus j of omega. Okay? So when you put that signal through this linear time invariant system, what is the response? You can go through the detail converting this into phasors and then put them through one by one, or if you're quick, you can just do that by inspection. Okay? If I were just to put this term through the linear time invariant system, what is the response to the first term? It would be 2, the magnitude of h of omega, and frequency 1, very good. Okay? And then cosine of omega 1t plus the angle that I have to add. And the angle I have to figure out, h of omega 1 is equal to magnitude of h of omega times the angle. The angle is e to the j arctangent of omega 1. Okay, this should be omega 1. And then the denominator is minus j arctangent. Or let me write it down here. E to the minus j arctangent of omega 2, omega 1 over 2, sorry, omega 1 over 2. So these are the total phases. Okay, theta 1 is equal to arctangent of omega 1 minus arctangent of omega 1 over 2. Okay, that is if I were just to put the first term through it. If I were to put the second term through it, I can also go through the usual machinery of converting this back into the phasor form, and then put it through it, and then reconstitute that back into the phasor form. Or I can do it by inspection. If I do it by inspection, then the response to the second term would be just equal to h of omega 2 sine of omega 2t plus theta 2 plus the necessary phase that I have to compute plus an additional phase. The additional phase is equal to arctangent of omega 2 minus arctangent of omega 2 over 2. Okay, that is the necessary phase that I have to add. Okay, that is the response to the second term, and then by the principle of linear superposition, you just add the two terms up to get the final solution. Okay? Is this clear? Okay, the last one is a little bit difficult. Problem 4. But it can be done anyhow. Okay, let's look at problem 4. Problem 4. You're given two signals. One is called f of t, the other one is called g of t. And the first thing you have to recognize is that the two signals are related by this relationship. Okay, one, if I were to draw them out, they look something like this. Kind of difficult to draw. One has no DC value. The other one is shifted, but also elevated by 3. I guess I don't draw well. Something like this, okay? If you look at the figure, which I have problem reproducing it quickly on the blackboard, is that the two figures are just related by this relationship. Okay? So you can look at the figure, okay? I can't reproduce it while on the blackboard quickly. So once you know this, you know the Fourier series expansion of one of them. You know that f of t has this Fourier series expansion. An pi over 4t, and n is equal to odd. Okay, only the odd terms are in sum. Okay, so then you can figure out what f of t of 2 is. And then what is 2 times f of t of 2 is. You will just have to shift it by pi n squared, and then n pi over 4 t plus 2. And then you have to multiply by 2 inside, and then sum over the n the same way. And then the shifting by 2 gives you an additional phase factor, so you get 6 pi n squared in this phase factor, and then you have e to the j n pi over 2. If you just work out what the phase factor is, because this 2 times 4 gives you 2, and then you're asked to find g1. Okay, what is g1? G1 is the case when n is equal to 1, you just substitute in to get g1. Okay, you substitute n is to the 1, you get g1. And then you ask to find g minus 1. G minus 1 is g1 complex conjugate, because this is the real signal. Because this is the real signal, they are related by this form, and you can figure out what g minus 1 is. Okay. And then the next part is slightly tricky. You're asked to find the Fourier series expansion of x of t. Okay, this is part B. X of t is equal to 1 plus sine t cosine of t. Okay? The best is to use the trigonometric identity and write this in terms of cosine or sine of 2t. Or you can use the exponential form or Euler's identity and write this as e to the jt minus e to the minus jt over 2j times e to the jt plus e to the minus jt over 2. This is sine, this is cosine, and multiply them out, and you should get 4 terms. 1 plus 1 over 4j, and then you can get e to the 2jt plus or minus e to the minus 2jt, and then there's one that's minus 1, this one that's plus 1. Okay, so they cancel each other, and then you're just left with only these 2 terms. Okay, and then you can look at this. This looks like a Fourier series expansion. There's a DC term there. Plus e to the 2jt. So, if you were to identify this as a Fourier series expansion, and if you want to look at what the fundamental frequency is, you can see that the fundamental frequency is omega naught is equal to 2. Okay? And then this is n equal to minus 1. This is n is equal to plus 1. Okay? And then you can, from that n is equal to minus 1 and n is equal to plus 1, write down the coefficient for the compact form. You can also convert this back into the sinusoidal form, or the sinusoidal form. There's a minus sign over here, sorry. When you compact and compress this, it becomes a sinusoidal form again. And then you can relate those coefficients to the coefficients of the compact form. And then you can also figure out the angle. Okay? Are there any questions regarding this? Yes?
On the previous one, for part A, so the last part, how did you get 6 over pi and squared? It's 4 times 2, should it be 8?
4 times 2, right? There's a 2 here.
Yeah, and then below, you wrote 6. 6 over, right below it.
Oh, 8. Sorry, this is 8.
Yeah.
Sorry, this
So
is
then the answers should be 8 over pi, correct?
8 over pi n squared, yeah. 8 over pi.
Yeah,
That's
so
right.
for 1 and
Right. So the answer G1 is equal to A8 over pi. This is equal to minus A8 over pi. Okay? Those are the two answers for that part.